Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your technical questions answered, and contribute to the community forum. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our construction tech or weekly Global Passive House Showcase webinars. In the meantime, here's this week's Passive House podcast. Well, welcome back to another episode of Passive House Podcast. It's great to have the whole crew back. I'm coming to you from Auckland. We've got Zach, as usual. How are things in Seattle, Zach?
They're good. It's beautiful out right now. Can't complain.
And joined again today by Ilka and Mary. How are you in Philadelphia, Ilka?
It's getting cold here. It was still really warm last week, and then all of a sudden it just kind of dropped, and I feel like it's almost winter.
And Mary, welcome back. Good to see you.
Thank you. It's definitely chilly here by California standards, but probably not as chilly as Philadelphia.
No, and well, we're a little bit damp here, but nowhere near as damp as it has been east coast of Australia. They've suffered massive floods for the third time this year, which is pretty catastrophic. There's something very crazy going on with the climate, and it's affecting east coast of Australia pretty dramatically at the moment. So, I hope everyone in that part of the world is doing okay. All right, we've got a great interview this week from Ilka and Mary, so really excited to dive into that. And there's a few things to talk about before we get into that. But before we do, Zach, should we give a shout out to our sponsors?
Let's do. Yes, a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingwe Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stillcorp, and Zola Windows. Thanks to our champion sponsors as well, Icon Windows and Doors, Intelligent Membranes, Proseco, and Source 2050. And a big thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority.
Great. All right. So Zoe Kaufman is a researcher that Ilka and Mary you spoke to this week. There's a few things I just want to check people know about before we press play on this one. Firstly, NREL. Be pretty familiar with a lot of people in the US, but for those of us who are outside and may have heard of it, can either of you give us a quick description of what NREL is?
NREL is a National Renewable Energy Laboratory. It's one of the, I think, 9 U.S. Department of Energy labs, research labs across the country. And they do a lot of renewable energy, but also building science related research there.
And probably quite influential behind the scenes. We were discussing just a moment ago, we haven't mentioned them much on the show before, but pretty important group, and they do some great work, which we're going to hear about. And the other thing I want to just touch on is WWOOFy. Okay, give us the full name of WWOOFy, because I've tried and failed.
Yeah, now that you have German here. So it stands for Wärme und Feuchte instationär, which is basically the looking at the heat and moisture that travels through the wall. You basically use it for hygrothermal analysis on new buildings. You can check out here if your assemblies work well in your climate in that way of, the way you layered it. But it's also important, and Zoe talks about it a little bit on retrofits, right? Because you want to see when you retrofit a building, you want to make sure that you layer the insulation in the right spot. So you can look at the hygrothermal analysis there. And what is actually important is that you kind of know what is already in the wall, right? Like what's already there and the type of material that's used. And sometimes you actually go out and do quite a bit of on-site measurements in terms of how much moisture is already in that material. And then you can basically calculate that into your hygrothermal model in WFI.
Yeah. Very good. And of course, those using Fierce will be very familiar with WFI Fierce, WFI passive, but that it's not also exclusive to Fierce. It can also be used just for hygrothermal modeling, which is a very good thing to do if people are unfamiliar with or worried about moisture accumulation in the building envelope. All right, well let's jump into it. I think Zoe does a pretty good introduction to herself. So we'll jump into the interview and we'll check back in afterwards.
Welcome, Zoe Kaufman, to our podcast. And you're a research engineer at National Renewable Energy Laboratory, which is one of the U.S. Department of Energy's national labs based in Colorado. And it's exciting to have you here. Let's get started with how you ended, like the first steps that got you there. So you studied biology as an undergraduate, but then got a master's in sustainable design at Carnegie Mellon University School of Architecture. And how did you make that transition and what inspired it?
Well, first of all, it is great to be here with you guys. I've been a longtime listener and participant in all things Passive House Accelerator, so I'm happy to be with you on the other side of this. I did start out in biology, and I was doing biology research. I knew that I didn't want to be a doctor of any kind, but I thought maybe I wanted to do research in biology, but it turns out that often it involves a lot of animal testing, and I am vegetarian, and I was pretty conflicted and started wondering when I would be able to do more good than harm, and I didn't have a great answer to that. So it was time to shift focuses. And I wanted to do something positive still with something related to whatever I was interested in. And I didn't exactly know what that was, but I was always interested in architecture and design. So I applied to several sustainable design programs and ended up at Carnegie Mellon in their sustainable design program in their architecture department. And now I do what I am happy to be doing, and I didn't necessarily know it at the time, but I got very lucky. So that's kind of how it happened.
And then at Carnegie Mellon, that's where you actually got quite a bit of hands-on experience, correct? With the Solar Decathlon?
Yeah, and it was a hands-on program at Carnegie Mellon in general, I would say, because I didn't have pretty much any experience in building and construction. I was learning a lot along the way, and luckily the program itself was a lot of learn by doing. So I was picking things up along the way. For energy modeling, we were doing projects that involved energy modeling. We were learning passive design principles by doing our own projects on our own homes. And we had a zero energy design class. So kind of along the way, anywhere where I didn't know what I was doing, I was picking it up. And so the logical next step really was to participate in the Solar Decathlon. At the time, actually, the Solar Decathlon was still called the Race to Zero. The design challenge was the Race to Zero, and the Solar Decathlon part was the build challenge. And I can still say from the other end, as I do help out with the Solar Decathlon from NREL's end, it is the perfect thing to bridge the gap between education and starting in the workforce with sustainable design and consulting and anything in that realm. And it was a great experience because I could just apply exactly what I was learning to a project where we had to defend all of our choices. And it was a fantastic learn by doing experience in itself too.
So what was the building that you guys were designing for that competition?
So the build challenge is generally the challenge where you're actually constructing a building. So we were doing a design of a theoretical building, which was a very place-based, Pittsburgh-specific home that could be kind of replicated in Pittsburgh and similar climatic regions. And it was a little bit of prefabrication and taking into taking all of the concepts that we were learning in kind of zero energy design, such as new technologies like ERVs and heat pumps and things like that, and incorporating it all kind of in a integrated design sense as well. So yeah, early days. The Solar Decathlon has really expanded in so many ways and evolved since then. And I really actually admire all of the students who participate today because there's so much more for them to demonstrate in terms of their skills and their knowledge, and so many different more aspects of the competition. So it's really exciting to see what they bring in, and it teaches us as well, what's coming down the pipeline and what's going to be the next exciting thing.
So was that back then your first kind of exposure to passive house, or was that not yet part of the building envelope consideration?
Passive house was definitely an inspiration for our envelope design and mechanical systems. Passive house was a small part of our curriculum. And I would say more of my exposure to it was when I was in my first job and actually just started to work on passive house projects.
So what was your first job?
I worked at the Levy Partnership and Systems Building Research Alliance, which is the nonprofit side of Levy Partnership. I did a lot of different things. It was kind of the perfect kind of first job because I got exposed to so many different aspects of what it means to do sustainable design consulting and design itself. I helped facilitate the Energy Star for Manufactured Homes program. I learned a lot about manufactured homes in the process, got to do some research projects and go to manufactured home factories and watch how everything was put together and constructed, and instrument some sensors in our test home that was zero energy ready manufactured home that we then were taking data on later on. So I got to do some data analysis there. And I also got exposed to other types of field work like HERS rating and Energy Star rating, and even some retrofit projects and building energy audits. I was working on a project with FEMA where we were standardizing, creating a standardized design for kind of climate proof disaster relief homes that could be placed anywhere in the contiguous United States. So that was a very, very different experience. And then ultimately, I was brought on to a couple passive house projects that were single family and small multifamily, both PHI and FIAS passive house projects. And then I kind of fell in love from there.
Well, and I understand you went on to take both trainings, actually, the PHI consultant training and the FIAS one. What inspired you to do both of them?
Yeah, well, I was on both types of projects, so it kind of made sense to dive in and do both of those so that I could be the certified passive house consultant on record for any type of those projects. So first, I took the FIAS training and certification, and then I took the PHI training and certification. And honestly, I felt like they were great preparation for one another, and really enjoyed learning kind of the concept to practice of both of those certification programs. And I felt like they really went hand in hand. And it was also really helpful taking both of those trainings back to back to understand any of the differences between them. So it was really fresh in my mind, and I could remember easily, okay, what happens in this standard versus what happens in this standard. And that helped me later on when I was at Bright Power as well, doing a lot of passive house consulting with both programs.
So Bright Power then was the next job that you took, correct?
Yes.
And can you tell us about that?
Yes. So I was doing probably primarily passive house consulting, although I was doing a above code program consulting in general. So this was now kind of a jump to larger buildings, and Bright Power focused on kind of larger multifamily specifically affordable high performance buildings. So this was kind of a new thing to me, and it was a really interesting experience to focus on affordable housing, and that meant a lot of details and specifics that I hadn't really thought about before. So in the context of passive house, for instance, primary energy use requirements were challenging with affordable housing because a lot of affordable housing might be senior housing or supportive housing, and you have a lot of studio and one bedroom units in that type of building. And so when you have one person per unit, you have a lot of appliances and ventilation per person. So it's that kind of thought that had to be put into to certification and trying to figure out, okay, what else can we do to be able to meet the standard if at all possible.
Yeah, and that goes hand in hand with heat generation by the occupants, right? So I know that sometimes that's a challenge to meet the cooling loads as well on those projects.
Yes, very true. Yep,
Yeah.
When you have high density, it was certainly challenging to meet cooling load. Yep.
And is there a difference between the PHI and the FIAS targets for those projects?
Yes, and so that's something that I was able to help kind of help developers figure out what program might be best for them based on the building typology. I mean, not in terms of targets, but even just in terms of like airtightness requirements. Obviously, the two programs have two different targets, one being based on envelope and one being based on your volume. And so they each favor kind of different aspect ratios of your building. And so if your building is flatter and more spacious, you might go with one, whereas if your building is tall and compact, you might go with the other. So, but yes, there were, I would say, so this is going to date me because I was doing consulting prior to 2020. So it was a lot of FIAS 2015. And, FIAS targets were climate specific. So that was a great help for sure in terms of, I would say, cooling load, especially even though it was difficult to meet cooling load at times. But it was helpful to have climate specific targets, but that sort of all changed up once FIAS changed its targets too.
And how different did this end up being in actuality in the buildings? I mean, this kind of juggling the different standards, did the buildings change that much, or how did the choice of which target you were going for affect the actual assemblies?
So I can say, back when I was doing this, if you were certifying under PHI, you were essentially always using triple pane windows. So that was a main difference that people often point out, I think. If you were doing FIAS in New York City, you might be able to do double pane windows, which was a huge upfront cost savings in a lot of cases. So you could model that thermal comfort and durability and moisture issues would be addressed even if you had a good double pane window. Whereas with PHI, you pretty much just went to the triple pane. There were other certification differences, just subtle differences in what you verify and also what you put in your model. If, for instance, a product is Passive House certified versus not, and kind of the safety factors that you have to put on it in case it's not Passive House certified. Central systems were a big issue. I think, especially at first, central systems weren't. There weren't that many of them certified with PHI, and so it was a little bit easier to go with FIAS for some of our projects that chose to do centralized HVAC. What else? I mean, the modeling software was certainly a difference, and I think with single family, I didn't notice much of a difference between them. PHPP, you could put in the inputs, Woofy, you could put in the inputs, fine, whatever. But when it came to a really complicated, maybe mixed use, large building envelope, if you had anything that was maybe curved sides or, anything kind of really architecturally interesting, we'll say, it was challenge to go from SketchUp to Woofy. I don't know if that's changed. But it was, that part in itself was time consuming. Whereas if you were using PHPP, you could just, enter the values. So there were certain challenges that I ran into just working with larger buildings.
You also did some retrofit New York work while you were there too, right?
I would say I tangentially worked on a retrofit New York project. I was brought in specifically to do some hygrothermal modeling on their roof assembly because they were looking at the roof construction and how much insulation to put on the exterior versus in the cavity. And so they wanted to make sure there weren't moisture issues by adding, too much cavity insulation compared to exterior insulation. They were hesitant to put more exterior insulation because there were space issues and height issues on their roof, and they had to maintain a proper slope for drainage. So it was a very meticulous process where we were trying to maximize the ratio of internal to external insulation without creating moisture issues. And that is sort of when I got deeper into hygrothermal assessment and WUFI hygrothermal modeling. And that's kind of what actually led me to my job at NREL now. Because I was very curious and always wanting to learn. And that's sort of where my curiosity took me.
I'm curious about this roof assembly on a retrofit, because a big part of that is also investigating what's there, right? Doing all the testing about materials that might not be in the database, right? And just looking at how much moisture there is in those assemblies already. Is that something that you did then as well, like the on-site testing?
That's a really good point. I mean, so much can be said in terms of garbage in, garbage out. And if you think that's true for an energy model, that's just 110% true for a hygrothermal model. I did not look at the properties of the specific materials that were in that retrofit project in particular, but we did know pretty well what the materials were, more or less. I mean, age wood members, in terms of framing, and we knew what kind of insulation they had, and I can't remember. They might have just been re-roofing anyway, so I think it didn't totally matter kind of what membranes they had on there. But yeah, it's a little fuzzy for me now, but it's certainly an important thing to do when you're creating these models, especially for retrofit projects, and you don't, have the material specifications in front of you.
Yeah, I feel like that's always one of the most challenging parts of energy modeling or hygrothermal modeling in retrofits, especially if you have, like here in Philadelphia, we have a lot of exposed brick, and each brick can be completely different. There can be different kinds of brick, on the south versus the north side. So you really have to go in and just kind of investigate what's there, because as you said, otherwise the hygrothermal model is really not worth much.
Yeah, you could probably go down as many rabbit holes as you want to and take forever testing your materials for all of their different properties.
So you said that your interest in hygrothermal modeling is what got you to NREL. Can you tell us a little more about that?
Yeah, so as I was investigating that retrofit New York project, and as we were hoping to increase those types of services at Bright Power, I took, I believe, a kind of intermediate hygrothermal modeling WUFI course, and it was taught by my now center director, along with someone from Oak Ridge. And I just really loved learning more about it and wanted to keep learning about it, and ended up at NREL in order to take on some hygrothermal projects, as well as other kind of building science and passive house tangential things, where there wasn't quite as much of that with folks being in the passive house world. So I do now get to do some hygrothermal related projects. I don't necessarily do them on like one-off type projects, but a lot of research related things. Obviously, there's one project that we wrapped up last year that was an internally funded project where we were using moisture analysis to understand the durability of wall assemblies in extreme cold climates as climate change occurs. So we recently merged with the Cold Climate Housing Research Center. And so a lot of my colleagues are in Alaska. And so we now have this new capability of looking at extreme cold climates, and climate change is affecting them more quickly than it is the rest of us. And so we were looking at various potential climate change scenarios and what happens with existing buildings and their wall assemblies, as well as potential retrofit walls. And it was a small project, so we're hoping to be able to do more of that work sometime soon, maybe not just in extreme cold climates, but other locations as well.
Right, because as your climate is shifting, your buildings are getting exposed to different conditions, and could set you up for some big problems, I guess.
Exactly. Yeah, we see acutely that we get maybe more extreme cold or extreme heat, but what matters more in a hygrothermal model is the weather trends. And so what we see in terms of trends is maybe a more humid environment, or for circumpolar regions, it might be a little bit more humid as well as just warmer throughout the year. So that means that times where the water was frozen, it's now water and can seep into your walls and can't dry out as well. So that's the type of analysis we were doing.
So what kind of climate data do you use? Like, how do you adjust it towards these different scenarios?
This is where I get a little fuzzy, and my colleague Tanushree Charan was the one who was doing kind of the morphing of the climate data. So there are various proposed methods to look at climate change scenarios. I am not an expert on them, but what we ended up doing is looking at various options. So kind of taking what happens when it is kind of your TMY data, which is maybe older data. It's not taking into account the last 20 or so years. And then we looked at the last 5 years, I believe. So what if trends were the same as they were the last 5 years? And then we looked at a scenario where it was generally warmer and a scenario where it was generally a little bit colder. So we kind of got to bookend the potential climate scenarios and then worked within there to see when our assemblies were having more issues versus doing, where they were doing a little bit better.
Mm-hmm.
So in addition to all the retrofits of existing buildings that people are talking about that need to be done, the large numbers that are there, there's a whole nother set of possible retrofits that are going to need to be done to buildings where the climate is shifting, and they've been built for one climate, but they may have to adapt to a different one.
Yes.
It's having to scale up low carbon retrofits is an even larger set than maybe people are thinking about.
I think that's very true. And this is part of why I would love for this research to be extended. And hopefully people think that it's important enough to look at, even though we don't have, 100% surety on our guesses for what future climate change is. It would still be good to look at the possibilities. And then, in terms of low carbon retrofits all around, I do think that we need to be looking at hygrothermal implications and making sure that we're not introducing vapor sandwiches accidentally, or just slapping on an inch of insulation where it's convenient to do so, and making sure that we're allowing our buildings to dry. And I think that goes along with improving our education about how to retrofit. So that will probably be pretty key there.
So I'm curious, one of your kind of backgrounds is in looking at pre-manufactured buildings. So do you see the scaling up of retrofits going that way as well?
I do think that that has a lot of promise. I'm not so much in kind of robotics and AI, but I do think that we're approaching the ability to energy sprung type approach where we're taking pre-made panels and just attaching them straight to the building. I think that is a lot of what the DOE's advanced building construction effort is focusing on. And there are certainly projects that are coming out of that and products coming out of that will allow for that more easily. My experience has been more with new construction, pre-manufactured and modular and manufactured homes. So I can't speak to it from what I've seen in the factory, but I do think that technology is getting there right now.
And so are there, in your work with now at NREL, you have done some consulting for manufacturers of prefabricated building components, yes?
Yeah, so in particular, I was recently able to work, excuse me, with a modular developer. They are a vertically integrated, affordable modular developer called Blockable. And we worked with them through this kind of unique program called the Wells Fargo Innovation Incubator, or IN2 program. And that program kind of takes companies in their somewhat startup phase in both buildings and agriculture. And they partner with NREL to provide assistance in terms of technical support for improving their technology or getting it to market, kind of whatever that step may be. And so originally NREL was focused on helping Blockable incorporate zero energy certification into their factory line. But ultimately, this project really became this decarbonization roadmap for the company as they scale and grow. So it wasn't just about zero energy performance, but also decarbonization all around. So it was kind of this life cycle assessment mixed with a cost assessment, leveraging their kind of productized, we call it, approach in terms of being able to take advantage of learning effects in the factory and outside of that, and improve upon the products they use and the methods of construction, and ultimately get to 60% carbon reduction by 2030, based on kind of our incremental changes suggested along the way. And they are following that roadmap so far. So it's really exciting. And it was also really interesting to see what, if you're already at roughly zero energy performance, where do you need to focus to decarbonize? And the answer is really your upfront carbon. I mean, as well as making sure that you're electrifying and taking advantage of grid electrification. But ultimately, after a certain point, it just really makes sense to look at the materials and products that you're using. So that's kind of where we really dug in.
So does NREL do a lot of research in terms of materials as well?
It does do some materials research. I am not involved directly in that research, but I know there are a couple projects like low carbon concrete research activities, and then Cold Climate Housing Research Center recently got received funding for a like mycelium, mushroom mycelium, as well as I think just generally cellulose insulation, both development and demonstration projects. So those are all interesting to me too.
I actually just read that IKEA is switching over to mycelium packaging.
Oh, that's great. Yeah,
Yeah.
I know that it's been big in packaging, and tested and is definitely available as a packaging product, but somehow is lagging a little bit behind in terms of wall insulation.
Yeah.
Maybe it's a fire hazard issue.
Well, that's exciting to get involved with companies where you can really have an effect on the evolution of their product line with this initiative that you were just discussing.
Yeah, it's a great opportunity, and especially understanding that, we're not looking at one-off projects anymore. And with a company like that, where they're creating this building product, and they're also the potential future owner as well, and they're able to benefit themselves from the investment that they're putting in at first. Like that's creating change at a larger scale, and it feels great to be able to be a part of it and help provide analysis for where it's going to be most effective to make small changes.
And you're also doing, you kind of hinted a little bit at, you're involved in the decathlon competition. Are you being a judge?
I am not. So NRELians cannot be jurors. I think that's a conflict of interest. But folks like you could be. So let us know. You may be interested, maybe for 2024. But in all seriousness, so we can be involved at various levels. Last year, I was I supported the jury in the multifamily housing competition for the design challenge, and you kind of coordinate and support all the efforts, as well as make sure that the teams have all of their deliverables in on time, and help run the competition in general. And actually this year I'm involved a little bit in the build challenge, where we are figuring out all of the measurements for anything from occupant comfort to energy performance to, we have now a passive performance contest, which is very exciting. This is the first time we're looking at it. So I guess I won't talk it up too much because we'll see how it goes this year, and we may need to tweak the rules for next year. But this is exactly, one of those opportunities where, the stakes are raised, and the students are stepping up, and we're seeing, what strategies they use creatively. So I'm really excited about this passive performance contest where for a couple days, essentially the power will be off, and we'll see whether the homes are livable and how well they do. And I just think it's an important challenge to demonstrate that this is important, and moving forward, as we have unfortunately more and more natural disasters and maybe power outages, this sort of resilience is what we're looking for, and this is how we're starting to measure it.
I think it's one of the underrated or spoken of benefits of passive house design and construction is the survivability when there's no power. So that's great that it's being included in the competition. Yeah.
I mean, it's such a testament to how, passive house principles are that first step towards all of these other related goals, like zero energy and reducing your bills and passive survivability, resilience. I mean, all of this is it's all kind of based on these simple principles.
Yeah, I think I like how you how Passive House can kind of plug into concepts like that. And what I feel is really interesting about just that concept of looking at, what happens if there's power outage, because a lot of the passive houses they do rely to a certain degree on systems, right? It's especially in hot and humid climates. So it's really interesting to kind of think about what happens if that fails, and is maybe looking at vernacular architecture, something that is beneficial, and can that be combined with those new building technologies?
Yeah, and this is starting to ask the question of, what is our threshold, and how long do we want to go without power, and are we trying to get to truly passive, and has Passive House really ever been quite about that? So lots of questions in there, but at least for Solar Decathlon, we're starting to ask the question, and we'll see how it all goes. This is kind of one big experiment, but I'll be interested to hear feedback about the competition and what were the major challenges, and whether there were any design decisions made differently just because of, for instance, the passive performance contest and other comfort contests.
Mm-hmm. Yeah, I mean, I feel like it's just so inspiring to see what NREL does. I actually checked out the website, which I have to admit I hadn't done before. I mean, I always knew what NREL was, but I never really dove into the website, and it's very encouraging. It's pretty amazing.
The amount of building science research that goes on at the DOE labs, I think, is many people are unaware of unless they directly interact with one of the labs in some ways. So, yeah. Well,
yeah, it's kind of a playground in some senses, and I've definitely been enjoying it, and also hope to do more, Passive House specific research in the future. So, any ideas? I'm open.
Yeah, that's a great note to end on. We really appreciate your time and coming to speak with us today.
Yeah, thank you so much. This was a lot of fun.
Thank you so much.
And that was Zoe Kaufman of NREL. Great interview. Thank you very much, Ilka and Mary. Should we start with you, Zach? What was your big outtakes?
Well, I mean, it was a super exciting interview to listen to. So yeah, thank you, Ilka and Mary. I was struck by a lot of things. One is how important the Solar Decathlon has been in this new generation of rock star passive house practitioners and thinkers. I keep on hearing about the Solar Decathlon and how formative it was for people, both folks who have done the build on the build side and on the design side, and I'm it's doing really important work in developing this industry and our industry's capacity. So I'm just really thankful for it, and excited also to hear about the passive competition that will be going on, and what that's going to reveal in terms of the power of Passive House to create resilient places for us to weather these crazy conditions that we're starting to see more and more of.
We've mentioned a couple of times it's come up, but if people are completely unfamiliar or don't know the details, then you go to solardecathlon.gov, and there's loads of information, including a map. And I'm very pleased to see that there's lots of dots on that map from all over the world now. They're talking about 124 teams in the 2023 Design Challenge, including a dot in Australia and a dot in New Zealand. That's exciting. Awesome stuff. For me, one of the things I have been hearing more and more about is people using future climate files, and I thought that was very interesting. Talking about not just using what has happened to model buildings, but looking at what might happen and what is likely to happen in specific regions, and designing on that basis, which usually means allowing for warmer conditions in the future, which I think is going to be becoming increasingly important. Mary, what stood out for you?
Well, that was definitely interesting to talk about in very cold climates that are changing pretty rapidly, and as you say, getting warmer or wetter. And how do you, going forward, how do you try and build for that when you know that the climate's just not going to be the way it has been? And obviously, hygrothermal analyses like WUFI are important to trying to figure that out.
Yeah. And also, it was interesting here, Zoe, talk about the different methods of doing that. It seems like people haven't quite settled on that yet, and there's a few different ways of doing that prediction of what the future might be like, because it's a little bit of guesswork, but it's interesting hearing how people are grappling with that. And what about you, Ilka?
Yeah, I think just the thought about the cold climate or the extreme cold climate stood out for me too, because I feel like we're have been focused a lot on the hot and humid climates to figure out how to involve Passive House there and look at those already hot climates that just heat up more and more. But I feel like for me, I tend to forget that there's also like these extreme cold climates that drastically change, and the buildings that just are in those climates are going to react completely different, or the assemblies in terms of moisture. And I thought that was really interesting, that's definitely something that NREL is focusing on, and that they have a cool climate research center to do so.
Yeah. I think it was really good that you asked about some of the other areas that NREL is working on, like retrofit options. Zoe has had experience with factory construction and prefabrication, offsite manufacturing, and I think it was great that you asked about what they see in the future. And it's great that they just seem to have so much going on there, and she's got so much experience across all those different areas. It's pretty incredible, and really it's great to know that there is an organization like NREL that is doing that work in the background to do such great research. Decarbonisation is obviously a really, really big thing, and that's emerging as a theme along with electrification. And it's great hearing people talk about Passive House as being a really good foundation for that. And I think it's a really good way of looking at Passive House as not being the be all and end all, but it's a great way to start to look after your operational energy and therefore operational carbon. But from that point, there's also extra work to be done to look at how that building is made up, to then start looking at reducing the embodied carbon in that building. So using Passive House as a pathway towards decarbonisation is also emerging as a bit of a theme. Awesome stuff. Anything else from anyone?
Well, I found it really interesting that when she was talking about the incubation project, the Wells Fargo incubation funding, and their work with Blockable, because they're trying to help advanced technology get into the construction industry while also trying to decarbonize the end product, which I thought was great.
Me too. And it brought up my favorite theme, which is learning effects, and the power of learning to drive down cost. And so she was talking about the 60% decarbonization by 2030, I think was the goal for Blockable. and that there was going to be, a series of incremental steps. And that's what learning effects support, and that's kind of how they work. It's like all these little tiny innovations that happen at all levels of delivery of, say, clean energy, or in this case, decarbonizing of buildings, that kind of transform a solution from being expensive and difficult to implement to cost competitive and scalable. So I was encouraged and excited to hear that theme come up in her description of the work with Blockable. It's cool.
And I feel like NREL has a little bit of an advantage too, because they're not just coming from the building industry, right? So they have a little bit of a broader viewpoint, and I think that's always advantageous that you kind of come from different sectors and you can bring some experience or practices from those as well. And what I personally liked a lot was that she also talked about that they're doing some material research, that they're looking into using mycelium as insulation material, and cellulose and all of that. So I thought overall it was very encouraging.
I think all of us wanted to become NRELians after the interview.
Definitely.
I think you just wanted to say that word, Zach.
I did it.
You got it in there.
Yep.
Yeah, I also wanted to say mycelium because I think that's a cool word.
That is a cool word.
And I'm looking forward to the first mushroom house.
Mm-hmm.
Indeed.
And NREL did a nationwide study that I don't think has gotten a lot of attention, characterizing all the buildings, residential and commercial buildings across the U.S., which I think is interesting research for any manufacturers that are trying to figure out, where to target their products. Yeah. Especially when it comes to retrofits, obviously, because if they know what types of existing buildings there are in which areas of the country and which climates, it'll really help with that. So, and that was something that came out from NREL in this last summer, I think. And
right.
There's more exciting research in that area that's coming out soon.
Yeah, I think that's a great point about looking at any generalization of typology can be really useful, so that people don't have to keep redoing the same analysis. Some analysis will be required for specific jobs, but if people can get a head start of that, of knowing what's worked before and come up with some typology that work in certain areas for both new builds and retrofits, that can be hugely valuable. Awesome stuff. Hey, thank you, Mary and Ilka, as always. I think we can probably find a bunch of links that we can put on this episode to share some of the information, some of the research that Zoe's been up to, because there's some great stuff there, and other things we mentioned like Blockable and the Solar Decathlon, and check those out, as well as some of Zoe's work on mycelium as well. All right. What have we got coming up, Zach?
Yeah, well, this week is Thanksgiving in the US. So at the Accelerator, we're taking a week off of Pass Accelerator Live, but we will be back next week on November 30th in North America. So that's December 1st for you in New Zealand and Australia. For a Project Showcase edition of the show, we're going to be joined by the Langlois Eco Homes team from Ontario, Canada, and they're going to be presenting Building Passive House on spec during a pandemic and in a weird market. So I think a lot of folks will be able to, a lot of practitioners who are taking these programs will be able to relate. And so please join us for that. Another announcement is just that the Passive House Network has its call for papers open for its 2023 conference. The deadline for submissions is January 31st. Of next year. The conference will be held in Denver this coming year, starting September 28th and running through October 6th. So get those ideas into the Passive House Network for potential presentations in Denver.
Nice place to be. Great. All right. Well, I hope everyone enjoys nice Thanksgiving.
Thank you.
Doing that, and we'll be back again anyway next week on Passive House Podcast.